So after you watch the notes for 6.3, your assignment for 6.3 is Delta Math. And there's two sections, and Mr. Mitchner is going to give you some time today to work on those in class. But one is on adding and subtracting square roots when you don't have any variables, and one is adding and subtracting square roots when you do have variables. And this was his 6.3A. If you didn't watch the notes yet, this isn't nearly enough to get the full gist of it. So go watch those notes. If you're at home, go watch them now and come back. But I screenshot these out of Delta, so these are representative. So if Jake got this one on his Delta, there's a property that says you can add and subtract like terms. And you had that when you were in middle school when they'd say, hey, what's 4x plus 3x? And you'd say, well, I'd have 7x's. It works the same for roots as well, but they have to be the same. And right now, this is a 50 and this is a 2. I cannot add them and say there's a 52 under there. They have to be like terms. Root 2 doesn't get any better. It's as good as it gets. But root 50 has a big perfect square in it. What times 10 and 5? That's not helpful because I don't know their roots, but you're thinking well. I need to know what the square root of one of them is. So I like that you said that because at least you, but I have no idea. I have no idea. There's something I do know though, hiding out in 50 that I know though, 25 and 2. Now sometimes if you can't think of those two, see this would be great because that's a 5, right? And then that's a root 2. I'm going to talk about if you couldn't see that though, but you're right. It'd be 25. Now I have like terms. I have 5 of those, and I'm subtracting 5 of those. My answer is 0 for this one. Yes, you need to have though those like terms, and so you need to simplify the roots. What's often helpful is if one doesn't simplify, you kind of know it's going to be the one hiding in there. So 2, I couldn't do any better. Now let's suppose though that Mason didn't see that 25 in there. I think and he used the 5 and the 10. Let's suppose you did that, right? Well, 10's not done. Right. And so now you have those 2 5s and the 2, and out pops the 5 because we say when those met. So either way, whatever you like better. If you spot it, it's faster. But if you don't, and you're like, well, I don't know, just find anything. Watch what I mean by that. Suppose it was the square root of 48, and you're like, I'm just going to deal with 6 and 8. That's fine, except I don't know their roots, right? We only know the square root of 4, 9, 25, 36, right? But that's okay, because Mason could say, well, that's 2 times 3, right? And this is 4 times 2. You can be like, almost there. But this is 2 times 2. So he's got a 2 squared, another 2 squared, and a 3. So, whoops, sorry, I put my root in the wrong spot, and a 3. So, pops out a 2, pops out a 2. So it'd be 4 root 3. But Parker might be, I saw that there was a 16 in there, LaRue. Why would I go through all that? And 16's nice, because what's the square root of 16? 4. Do you see how it's quicker if you can see it? But if you can't, don't leave it undone. All right, so let's do the next one when there's variables. Our goal is to get like terms. So I'm going to go deal with these roots. Nothing I can do with that.
The other one?
The other one's got 2 things I can do. First of all, I can pop out some x's. Remember, Parker, what do we do with those exponents? Divide. And 4 divided by 2 is 2. So 2 of them are going to pop out. So I'm going to deal with that first. All right. This first term, I can, and again, I took this right off of Delta Math, so you'll be generating similar ones, Betsy, when you start in about 2 minutes. All right. However, I can't say, well, hey, 6 plus 24 is 30. They have to be the same, right? So what multiplies to equal 24? That's a perfect square. Or if you don't know, find anything that multiplies to equal 24 and start breaking it down. So let's talk about the quicker way, and that's if you see it. There's a really nice one of these perfect squares that's hiding out. And again, 5 times 5, 6. These are the things we know the roots of. One's not helpful. Square root of 4 is 2, 9 is 3, 25 is 5. What one of those numbers is hiding out in 24? You guys can go ahead and tell me.
4.
4. If you can see it,
4 and 7.
yes. And I didn't know it was going to be 6 because remember I need those like terms, so that kind of triggers like what you're going to choose.
They equal each other.
So I'm going to do 4x squared, and then, right, they are going to be, yes, you're thinking around the right lines here. We said that's 4 times 6, and I'm showing every step because I'm only doing 2. Your notes will do more, but you should be, all right, so this is almost done. The only problem is, let's take care of this. The reason we chose 4 is we know it's root. What's the square root of 4? 2, right? That's why Mason said, oh, they're going to be the same thing. And they are. So we'd have the 8x squared plus 6, 8x squared times the square root of 6, which nothing could be done with that. But this guy over here, we pulled out the 2x's because Parker said you divide those. It tells you how many to pull out, 2 of them. But then this is also going to pop out a 2, so that's why Mason said, oh, they're going to be the same. That doesn't give you 0. Right? I have 8x squared plus 8x squared root x. I have 8 of these, they're like 8 apples, and 8 more apples. Those are like terms. What do you think I get when I add them up? 16 apples. You don't change the like term. A lot of kids will say, oh, x to the 4th. But x squared plus x squared is an x to the 4th. It's 2 of those. Yeah, so it's a little bit tricky. So once you have, same here, what's 3x to the 4th plus 2x to the 4th? 5x to the 4th. Does that make sense? Think of the apples. All right, so this is done. I'm going to stop recording, and that took us 7 minutes of our time.